Hi, my name's Dr. Stephanie Dowdell, and I'm the Best Network Manager. I've worked with the Best Network for the last 10 years, and I'm very excited to show you around the SLICE image bank today. The Best Network, or Biomedical Education Skills and Training Network, is a not-for-profit network or community of universities and academics developing and sharing technologies for image-based education and assessment. In 2013, the Best Network released SLICE with a common goal to enable the viewing, annotating, and sharing of high-resolution biomedical images. Over the last 10 years, we've developed a series of tools that enhance using images in classrooms. These range from a measuring tool that allows you to gather information about the sizes of cells and regions, to group annotation activities, MRI and CT viewers, collections that allow you to organize folders of images, layers, and questions to be shared and organized well as LTI integration and single sign-on that help streamline student registration and participation in class activities. Most recently, we've developed a drop-a-pin question tool that offers feedback and insight into feature identification. And coming in 2024 is a histology atlas that complements the virtual slides on SLICE. And in 2002, we were thrilled to win the OneEdTech Learning Impact Award for our work in facilitating inter-institutional sharing of large, high-quality images. We're thrilled to have a number of institutional partners who've come along this journey with us, and these include universities in Australia, where we're based, as well as international institutions. First, let's explore the options that academics have when teaching microscopy courses. They generally have three options and may use more than one. First, physical microscopes and slides. The advantage of using this is that students develop microscopy skills while they're exploring the tissues, which may or may not be relevant for their future studies. The con is that these resources can be subject to breakages, which adds to the cost of the resource. Class numbers are also limited because the number of glass slides and microscopes is finite. Then we have our online textbooks and histology atlases. Luckily, these resources do not limit class sizes, and the con is that content is static and can't be adjusted to fit your needs, your teaching images, or your teaching style. Then lastly, we have virtual slide solutions. The advantage of these is that the resources do not limit class sizes. All students, unlimited numbers, can be viewing the same image of the same quality at the same time. And it allows you to tailor your content to suit your classes. The disadvantage is that there is some work involved in selecting images and preparing content. So now let's look at SLICE, the Best Network's virtual slide solution and image bank. It's accessible at www.best.edu.au, and SLICE is our image-based online learning and teaching platform. You can see on the right that we have a variety of images here. So not only is SLICE a virtual slide solution, but we also support radiology images, macroscopic specimens that have been photographed, and photographs of dissections, diagrams, etc. And SLICE allows educators to view images from within our collection and also upload their own, and to create annotations on these. We also welcome students creating annotations. And this allows them to drop pins, as shown in this image down here on the left, on the bottom, on the left. They can drop pins, draw regions around features on images, and provide descriptions and titles. These annotation layers or the underlying image themselves can be shared with others, and we have a suite of tools that allow you to run activities to engage students. So now let's take a look at the types of ways that SLICE is used in classes. I'd say that the most common use is in microscopy practicals or tutorial sessions. Some of our institutions have completely replaced teaching with microscopes with SLICE. while others use Slice as a complement to their physical microscope sessions, allowing students to view the same slides outside of class. In the case of face-to-face sessions using Slice, teachers or tutors bring up a virtual slide on the main screen and walk through the slide for a student. I'm going to move over to Slice and do that now. Teachers and tutors start at low magnification and point out identifying features before moving to a higher power magnification. We zoom in using the mouse tools or the plus and minus buttons at the top. Slice allows you to zoom in right to the highest magnification and pan across the tissue. Now, tutors will point out features such as this sebaceous gland, explain what their function is and how they can be recognized, and students follow along on their own computers and make annotations on images to help them create a set of study notes. Slice is also useful for online and face-to-face lectures. It allows them to add images to PowerPoint presentations and hyperlink these to the images on Slice. When clicked inside the lecture, the lecturer can interact with the images at their highest resolution compared to the use of a static small-scale image. The teaching tools built into Slice also facilitate group work activity where students can work together in small groups to annotate an image, as well as for formative and summative assessment and classroom activities where students can receive immediate feedback on feature identification questions. Another use is in practical sessions where students focus on the appearance of physical specimens such as potted organs, commonly used in pathology teaching to examine the appearance of disease. Where physical resources are limited to 1 or 2 examples that are passed around the class, a high-resolution photograph that's been uploaded to Slice can give all students access both in and outside of the class and complement study with the physical specimen. So the Slice catalogue has over 22,000 images contributed by our partner institutions, and this includes over 7,000 virtual slides. You're welcome to use everything in the collection or contribute your own slides or images. And this has created a shared repository of resources covering a range of disciplines, including anatomy, pathology, veterinary science, diagnostic imaging, botany, dentistry, and hematology and microbiology, just to name a couple. So now let's run through some of the benefits of using Slice. As I mentioned before, Slice allows you to view images and create annotations on a wide range of images. And these images and annotation layers can be shared with others for a number of teaching purposes, which we'll run through in a moment. And our tools allow you to engage students in class activities. Slice is available online, anywhere, at any time. And one of the great benefits is that you can access resources from other institutions. First, let's start with our search capability. With over 22,000 images, we have taken care to catalogue these with all available descriptive metadata. And examples of this searchable metadata include body structures like pituitary gland, keywords, is the tissue normal? Is it part of a collection of veterinary images? Species, both common names and scientific, stains for virtual slides, and any disorders that are present in those images. We've added additional filters to allow you to return a smaller number of images as part of the search, so you can filter for just microscopic images, macroscopic species, for example. And you're also able to combine your search terms. So combine a body structure and a disorder, for example, to help limit the search results. Now let's take a look at the annotation tool. It allows you to mark regions of interest on images, either for personal use or to share with others. And I'm going to jump onto Slice now to show you an example of a layer. Going back to our skin specimen here, I'm going to turn off full screen mode, and this will open up a list of the layers and public layers that are available on Slice. For new members, you can create layers by clicking Add Layer, But first of all, I'm going to turn on my features of skin annotation layer that I made earlier. It has 9 annotations, and I have marked up several features of interest, including the layers of the epithelium, the skin layer, tattoo ink in the skin with these pins, and examples of these sebaceous glands that we talked about before. So some of these annotations I've provided descriptions for, and I'm going to open up this sebaceous gland annotation. You can read the text-based descriptions that I've added, and you can see that I've marked up several of these regions on the image. So you can have many examples of the one feature marked up on the image. Each image has its own URL, each layer has its own URL, and you can share access to exactly what you're trying to share with people very easily. So I'm just going to add another annotation now by clicking Annotate, Sebaceous gland, and I would use this description field to describe the function of this gland. So it produces sebum. They are commonly associated with hair follicles, for example, and I'm just going to show you how we can mark out these features on the image. So we've got a pin. This will follow me around, and I will choose the spot that I'd like to place that pin. We can have multiple pins to mark out that feature. We've got circle and rectangle tools to use these. We select the tool, move to where we'd like to start, and I will hold down my mouse key and stretch that out so that I draw around the shape that I'm trying to mark, the feature, and drag in those edges if required. But my favorite tool is the draw tool. So using that, I've got the crosshairs. I click once to start the shape, and then I continue to click around the outline of the feature to mark it very nicely, considering its shape, and double click to finish. So here I've made 4 shapes, 2 pins and 2 shapes. And when I'm finished, I will click done, and this becomes part of the shared layer. So students are able to do this while their tutors are discussing the slide with them, pointing out the features, and on their own devices, in their own accounts, students mark out these features to create their own personal notes, or academics can do this either in the session or before the session to have a shareable set of notes. Okay, so now back to my slides. Let's talk about why academics may annotate. So firstly, it's to highlight features to draw attention to while teaching. This may be because there are rare or hard to find features that you want to spend time before class marking these out, perhaps a mitosis in a cancer specimen that can be hard to find. Once you've placed a pin on it, it's very easy to demonstrate and find that feature in the middle of a class without spending too much time. They also remind you what you wanted to discuss in the class. They make a very professional looking set of notes that can be either shared with colleagues to share the load in preparation for classes, or for sharing with tutors who will also be teaching those classes, so that you know that all tutors have the same level of knowledge and know what needs to be discussed with the students in the class. They can also be shared with students after class if the students aren't being asked to annotate, to review what was covered as a set of correct examples as an example. Academics can also create layers where features are marked but not labeled, to encourage students to prepare for a class by thinking about what those features might be. So now let's think about why students would annotate. We know that note-taking is an important part of learning. The act of writing something down or interacting with something helps you consolidate your learning. So the annotation tool allows students to mark regions or features that are discussed while in class, or can be used in private or group study. What I have on the right is an image of a student-created layer, and they've marked up 4 features by placing pins and have described these features as discussed in class. And this provides them with a set of in-context notes that is particularly important for exam revision. Now, if you imagine they're relying on written notes, diagrams that they've drawn, or even a screenshot. These notes may not accurately reflect the location of these features and can be very difficult to come back to during study sessions. Whereas if they just copy the link to their layer on Slice, come back and have a look and revisit all those features, they can exactly see where those features are in context of the slide, how close they are to the layer of the epithelium, for example, in my skin, or how deep it is in the tissue. Another important example is that they can be used to ask questions about the content they were taught. So if you think back to teaching with microscopes, if you had a question, you were trying to describe the position of a feature and its color on the area that you've chosen to show under the microscope. Or maybe you were lucky to have one of the eyepieces that had the arrow that you could point something out to. But with the Slice annotation tool, just have to place a pin on the feature that you're trying to ask a question about. And this can be either shown to a tutor in the class session, or it can be emailed at any stage, and the tutors are able to respond to answer the question. Now, every layer is private until it is shared or has had members invited to participate on it. And you can use annotation layers to create group activities for students. Firstly, layers created by students and shared among themselves by clicking the invite layer and sharing that link can facilitate small group annotation layers where students are working collaboratively in the middle of a class to mark up all the features of importance, and they all share that layer. Or alternatively, we can run large group activities, such as what is shown on the right here, where a teacher starts the layer, shares the link in their learning management system, and large groups of students, such as the 106 members that we have here, can all attempt an activity knowing that their annotations are anonymous. So you get better participation in the class activity. Here they've been asked to place a pin in certain features, and it ultimately creates this heat map on the image that can be discussed in class. And it's wonderful for gaining insight into students' understanding and can be used to tailor feedback to students in the class. However, the feedback is all manual and done via discussion. So now we move on to the question tool, the drop a pin tool on Slice. So what we did was take the best features from the annotation tool and the collaborative group activities and create this question tool that allows our academic members to create a question, select a single feature, and mark out all correct regions on that image. And we know that some of the slides, particularly for perhaps a normal specimen where you're asking them to identify a feature, that feature may be repeated multiple times across the slide. So we've set it up so you can narrow down the field of interest to only a portion of that slide. So you can just then mark out the correct regions in that area. So we mark those out. We get the link to the question and share that with students. And students then interact with the question by dropping a pin, similar to the annotation tool that they're already using, to identify the location of that feature. And they check their response. They receive immediate feedback as to whether they are right or wrong. And at the end of the attempt, they can see the correct region outlined to them. For our academic members, they're able to review all of the student responses and gain insight into their students' understanding. How many attempts did it take them? How many thought the feature was elsewhere on the slide? And allows them to review the misconceptions and tailor discussions with the class, also knowing that everyone has received immediate feedback. So let's go and take a look at a question, answer one, and see what the academic view is like. Okay, so what we're looking at here is an example of a question. The information regarding the specimen itself has been provided to the students at the top here, so they know they're looking at a portion of human anterior pituitary gland from a patient who has suffered a partial infarct and that this tissue was stained with H&E. So any information they need to know to answer this question. Then within the anterior pituitary gland shown, Identify the dead and dying blood vessels or capillaries by placing a pin. So we collect our pin, we can zoom in and out on this specimen, take a look at the tissue, place that pin where we think the correct region is, and check response. For this question, students were given 3 attempts. For our summative style questions, you can set it as 1 attempt only and no feedback is shown to the students. So I didn't find it in my first attempt here. I'm going to zoom out a little bit and try again. Collect another pin and place it in one of these areas here, where I believe the dying blood vessels are. Again, I'll check my response. This time I have correctly identified it. I can see my previous attempts as well as any other feedback areas that have been identified. And I've completed the question. I'm going to swap now to the academic view of this question. So you can see pins scattered all around this image. It's a beautiful heat map. The students that have answered correctly, their pins have fallen inside this green region, but we can also see clusters of incorrect pins in other areas on the slide. For example, in the normal tissue shown down here, and the vessels that have colloid in them up the top. So we've got 242 responses from a total of 115 students, who are all by default anonymous. There are settings that allow you to filter these responses to show only correct or incorrect, or show respondents' names. And what we end up being able to do is tailor the discussions in a class to address any of these misconceptions and discuss what the students are thinking about them. So for this example, the normal tissue and the colloid vesicles, they were actually addressed in other questions. So feedback wasn't provided for them. But what was really interesting was the large number of students who are identifying this artifact as the dead and dying blood vessels, as well as this one. So additional feedback annotations were created to address these, and they were discussed in class. Our next tool for discussion is the collections space of SLICE. This allows you to organize folders of images, annotation layers, and questions to share with colleagues or students, or simply for personal use. So shown on the right is the collections area, and you can create unlimited numbers of collections for different purposes. We also have a number of automated collections, such as images that you've marked as a favorite, any that you've annotated on, and any that you've made questions on. They're automatically organized for you. But for those of you organizing a course, can create a collection for each course you teach with sub-collections for each week, and you can add all the individual images and layers that students will be accessing for that week. So here in the histology course, Lab 1 focuses on the introduction to histology and basic tissues, and there are 14 images that are used as part of this course. You can add layers as well and place them in the right position so that students know exactly which image they're accessing first. Another nice feature is that it allows you to set the images and layers to load at chosen areas and magnifications, so you know that when students open them, they're looking at exactly the right part of the tissue so that you can discuss it as a class. The next feature for discussion is the Histology Atlas that's being released in 2024. It's been built in the Open Learning platform and provides a guide for students learning about the microscopic structures of tissues. It's been created for those studying histology and histopathology who need to revisit the appearance of normal tissue before they go on to look at the effects of disease on the microscopic structures of tissues. The atlas has been organized by body structures and can be very easily navigated to find content that is relevant to what students are studying. We've included annotated images from SLICE along with diagrams and text-based descriptions. And not only is this a great resource for students studying histology or histopathology as part of an existing course where the atlas complements the learning with SLICE, that's created by their institutions, and this becomes a reference resource, but it can also be used by new institutions who are looking to set up a histology course, as we have ready-made sets of layers, images chosen, and descriptive information that can form the basis of a course. So just to show you quickly around the histology atlas, we have our lists of body systems on the left, and when we select a module to look at, they're organized into subcategories. We'll take a look at the epithelial tissue, which has been broken down by the different types of epithelium. Here we'll have a look at the simple cuboidal epithelium. Pages are structured with sections of text and diagrams, and as we move down, we come across the annotated layers from Slice that have used our LTI tool to be directly embedded inside the atlas. We can select the annotations, zoom in and zoom out, and navigate down to see additional examples. So one of the best parts of my job is the opportunity to learn from and support academics around the world. I've included a couple of quotes from some of our academic members who highlight some of the ways Slice has supported teaching at their institution. Professor Nicodemus Tedler at UNSW was the first to put up his hand to trial the question tool, and having gotten the opportunity to sit in on the class myself, I can agree with him that the question tool was great fun. Every student was engaged and discussing with their peers, and at the end we had this beautiful heat map that I showed earlier that showed all the student pins, and Nicodemus was able to provide additional feedback to address misconceptions like where students confused an artifact with the feature. Dr. Noelia Roman of Charles Sturt University, as part of her work with Slice in the classroom, supplemented face-to-face tutorials with physical microscopes. And in her weekly sessions using Slice, she was able to provide a blended teaching approach. The annotation tools helped her assess how students were applying theory content. Associate Professor Shashi Murthy from James Cook University was one of our first contributors to the image bank and contributed some rare examples of blood films. One of the key features of Slice and our community is the ability to draw from the teaching collections of other institutions to provide students with the best possible examples for teaching. Dr. Martin Weber from UNSW was responsible for a lot of the pathology teaching for students completing their medical studies at rural campuses at UNSW. Without Slice, it would have been impossible to run these tutorials around macroscopic pathology specimens and that had been photographed and placed on Slice, as well as the virtual slide collection, which gives both local and remote students equitable access to resources. So if you'd like to test out Slice, you're welcome to register for a free 30-day trial. Our subscription plans are all listed online and suit classes of all sizes. If you've got any questions, you're most welcome to get in touch with me to discuss how this might work in your classes.